Hello student, now we'll start the new chapter, sets and relations. The first is A union B is equals to X is such that X belongs to A or X belongs to B. Now the next, A intersection B is equals to X is such that X belongs to A and X belongs to B. A complement is equals to X is such that X belongs to U and X does not belongs to A, where U is the universal set. Next is A minus B is equals to X is such that X belongs to A, but X does not belongs to B. Next is A symmetric B is equals to A minus B union B minus A. N of A union B is equals to N of A plus N of B minus N of A intersection B. Next is next formula. Say this, N of A union B union C is equals to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Next is A cross B, that is a Cartesian product, is equals to xy is such that x belongs to A and y belongs to B. Relation R from set A to set B is a subset of A cross B domain of R is equals to, in curly bracket, x is such that xy belongs to capital R and x belongs to A, y belongs to B, is a subset of A. A range of R is equals to y is such that xy belongs to R, x belongs to A, y belongs to B, and it is a subset of B. R is a relation on set A, and if xy belongs to capital R, for all x belongs to A, then R is a reflexive. R is a relation on the set A, and if xy belongs to R, then yx belongs to R. For all xy belongs to R, then R is called the symmetric. R is a relation on a set A, and if xy belongs to R, yz belongs to R, then xz belongs to R. For all xyz belongs to A, then R is transitive. Now the next is, if capital R is reflexive, symmetric and transitive, then R is an equivalence relation. Now the exercise 5.1. Describe the following sets in roster form. A is equals to x is such that x is a letter of the word movement. Therefore, this is very simple problem. You can write all the letters. It is from the 9th standard question. Now the second, b is equals to, in curly bracket, x is an integer and x lies between minus 3 by 2, 9 by 2. These are the numbers. Let's see again. For the second, x is an integer and it lies between minus 3 by 2 and 9 by 2, which is minus 1, 0, 1, 2, 3, 4. Third, c is equals to, in curly bracket, x is such that x is equals to n plus 1, where n belongs to set of natural number. The numbers are like this. That is a 3, 5, 7, 9 and dash dash. Question number 2. Describe the following sets in set builder form. That is only the single element, which is 0. There are the number of methods to describe x is such that x belongs to W, but x is not real number, not natural number. Therefore, we have only the single element 0. Second, b is equals to, that is 0 plus or minus 1 plus or minus 2 plus or minus 3. That is b is such that x belongs to z and x lies between minus 3 and plus 3. X is equals to 3. X is equals to minus 3 also. Therefore, we can write it is x is such that x belongs to z. X lies between and equal to minus 3 and plus 3. Next, c is equals to, in curly bracket, 1 upon 2, 2 upon 5, 3 upon 10, 4 upon 17, 5 upon 26 and 6 upon 37, 7 upon 50. C is equals to, x is such that x is equals to n upon n square plus 1, where n belongs to capital N and n is less than or equal to 7. This is we can construct this. That is 1 upon 2, 2 upon 5, 3 upon 10, 4 upon 17. Next is 5 upon 26. If you see this here, 1 square plus 1, 2 square plus 2, 3 square plus 1, 4 square plus 1, 5 square plus 1, 6 square plus 1, and in this way c is equals to, in curly bracket, x is such that x is equals to n upon n square plus 1, where n belongs to set of natural number and n is less than or equal to 7. Now next is 0, minus 1, 2, minus 3, 4, minus 5, 6. D is equals to x is such that x is equals to minus 1 raised to n minus 1 into n minus 1, where n belongs to capital N. Therefore, it's very simple that x is equals to minus 1 raised to n minus 1. If first we take n is equals to 1, that is minus 1 raised to 0, and 1 minus 1, it's overall it is a 0, and in this way we get the remaining all the numbers. Number 3, if a is equals to, in curly bracket, x is such that 6x square plus x minus 15 is equals to 0, b is equals to x is such that 2x square minus 5x minus 3 equals to 0. Next, c is equals to, in curly bracket, x is such that 2x square minus x minus 3 equals to 0. Therefore, in this case, then find A union B union C. Second, A intersection B intersection C. Now, in this case, we want to solve all these quadratic equations. Then we get all the sets, and then we'll find out the answers of this question. Now, first A is equals to x is such that 6x square plus x minus 15 is equals to 0. Now, this is a quadratic equation. We can solve it like this: 6x square plus 10x minus 9x minus 15 is equals to 0. And that's why if we take the common 2x in bracket 3x plus 5, and from this bracket we'll take minus 3 as a common, then in bracket 3x plus 5, that's equals to 0. Then for in first bracket 3x plus 5, in second bracket 2x minus 3, which is equals to 0. And hence x is equals to 3x plus 5 is equals to 0, or 2x minus 3 is equals to 0, and that's why 3x plus 5 equals to 0, 3x is equals to minus 5, x is equals to minus 5 upon 2, or x is equals to 3 upon 2. My mistake, I had written it is plus. And in this way, we have the set minus 5 upon 2, 3 upon 2. Set A has two elements, minus 5 by 2 and 3 by 2. Now next, for this we will solve this quadratic equation. X is such that x square minus 5x minus 3 is equals to 0. Therefore, x square, 2x square minus 5x minus 3 equals to 0. That is a 2 into 3, which is minus 6. Therefore, 2x square minus 6x plus x minus 3. Now take 2x as a common. Then in bracket x minus 3. From the next, take 1 as common. In bracket x minus 3 equals to 0. That is x minus 3 in first bracket. In second bracket 2x plus 1. That is equals to 0. Therefore, x minus 3 is equals to 0, or 2x plus 1 is equals to 0. Therefore, x is equals to 3, or x is equals to minus 1 upon 2. Therefore, b is equals to minus 1 upon 2, 3. Now, c is equals to, in curly bracket, x is such that 2x square minus x minus 3 is equals to 0. Therefore, 2x square minus x minus 3 is equals to 0. Now, the multiplication of the first and last term is a minus 6x square. Therefore, the factors are 2x square minus 3x plus 2x minus 3 is equals to 0. This is normal simplification of this quadratic equation. The values of x are x is equals to 3 by 2 and x is equals to minus 1. A is equals to in curly bracket minus 5 by 3. We have the set A is equals to in curly bracket minus 5 upon 3, 3 upon 2. B is equals to minus 1 upon 2, 3 and C is equals to 3 by 2 minus 1. Now the first question is A union B union C. We'll take the union of all these sets. See this here, minus 5 by 3, 3 by 2, union minus 1 upon 2, 3, and the union 3 by 2, minus 1. If we take their union, and then we have all the types of these, all the numbers. You can see this here. Okay. Now the next, A intersection B intersection C. That is there any common element? No. Therefore, now the next is the previous example. All these three had no common elements. Therefore, their intersection was 1. Now the next question number 4. If A, B, C are the sets of the letter in the word college, marriage and luggage respectively, verify that A minus in bracket B union C is equals to in square bracket A minus B intersection A minus C. This we want to verify. Now we'll write here A is equals to set of letters in the word college, that is COLEG, set of word letters in the word marriage, that is equals to MARIGE. C is equals to the set of letters of the word luggage, LUGAE. Therefore, B union C. Now the union of these two is very simple. You can write it is MARIGELU. This is the B union C. Now the next is A minus B union C. See this here, A minus B union C. G is there by mistake. Here is a G. It is corrected now. You can see that is COLEG. Now, which are the common element? G, E, L. These are the 3 and the remaining is 2. C and O. Also, A minus B is equals to COLEG minus MARIGE IGE. Therefore, their subtraction, that is equals to COL. A minus B. Now again A minus C. Now see this here. Which are the common elements? C will be remain as it is. L, G and E. These are the common. Therefore, the remaining is only C and O. This is their subtraction. Now again see this here. CO. Which are the common? L, E, G, L, E, G. Therefore, the subtraction is only CO. Now, A minus B union intersection A minus C is equals to, therefore, A minus B intersection A minus C, that is equals to in curly bracket COL union CO. Therefore, next. And hence, the common is CO. Therefore, from 1 and 2, we get A minus in bracket B union C is equals to A minus B intersection A minus C. If A is equals to 1, 2, 3, 4, B is equals to 3, 4, 5, 6, C is equals to 4, 5, 6, 7, 8 and universal set X is equals to 1, 2, 3, 4, 5 up to the 10. Then verify the following. A union in bracket B intersection C is equals to A union B intersection A union in bracket B intersection C is equals to A union B intersection A union C. Therefore, first we'll consider the LHS, that is B union C is equals to 3, 4, 5, 6 intersection 4, 5, 6, 7, 8 and that is equals to, which is the common element, 4, 5, 6. That is, this is the, therefore A union in bracket B intersection C is equals to, that is 1, 2, 3, 4 union 4, 5, 6. If you take their union, then you will get 1, 2, 3, 4, 5, 6. This is the A union in bracket B intersection C. Now A union B is equals to this. Now we will consider the RHS, which is A union B intersection A union C. Now first of all we'll find out A union B, which is 1, 2, 3, 4 union 3, 4, 5, 6. And that's why you will get their union is 1, 2, 3, 4, 5, 6. A union C is equals to 1, 2, 3, 4. C is 4, 5, 6, 7, 8. Therefore 1, 2, 3, 4, 5, 6, 7, 8. This is the A union C. Therefore A union B intersection A union C is equals to 1, 2, 3, 4, 5, 6 intersection 1, 2, 3, 4, 5, 6, 7, 8. Now they are common elements, which are 1, 2, 3, 4, 5, 6. Therefore, this is number 2. Therefore, from 1 and 2, A union in bracket B intersection C is equals to A union B intersection A union C, and it is a proved one. Now see this again. This is we have put. Now next is second. A intersection in bracket B union C is equals to A intersection B union A intersection C. Now again here we consider the LHS. A intersection in bracket B union C is equals to B union C. First we will find out 3, 4, 5, 6, 4, 5, 6, 7, 8 and their union. This is the 3, 4, 5, 6, 7, 8. A intersection B union C is equals to, now first is 1, 2, 3, 4, 3, 4, 5, 6, 7, 8. Now their intersection, the common elements. Which are the common elements? 3 and 4 are the common elements. Therefore, it is written as 3, 4. All these examples are easy. A intersection B is equals to 1, 2, 3, 4. 3, 4, 5, 6. Now what is the common? 3, 4 is a common. Therefore, A union C is equals to now 1, 2, 3, 4. Sorry, A intersection C is equals to 1, 2, 3, 4 intersection 4, 5, 6, 7, 8. And they all of them have 5, 4 as a common element. Therefore, A intersection B union A intersection C is equals to 3, 4 union 4. And that is nothing but 3, 4. This is number 2. And that's why from 1 and 2, we get A intersection B union C is equals to A intersection B union. That is A intersection in bracket B union C is equals to A intersection B union A intersection C. Now third, A union B complement, A complement intersection B complement. Therefore now consider the LHS. Now first A union B 1, 2, 3, 4 union 3, 4, 5, 6. Their union is 1, 2, 3, 4, 5, 6. Therefore, their complement 7, 8, 9, 10. Because the universal set contains 10 elements. Therefore, there is a 7, 8, 9, 10. Now the RHS, this is number 1. A complement is equals to the remaining element. B complement. These are the elements. We can write now. You can see the set A. Now their intersection. The common elements. That is A intersection B complement is equals to that is 7, 8, 9, 10. This is number 2. Therefore, from 1 and 2, we get A union B complement is equals to A complement intersection B complement. Now, fourth one, A intersection B complement is equals to A complement union B complement. Now, A intersection B, these are our given set, which is the common element. 3, 4 is a common element. Therefore, A intersection B complement is equals to, this is 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 10. Number 1. Now RHS, A complement 5, 6, 7, 8, 9, 10 and B complement 1, 2, 7, 8, 9, 10. Therefore, their union, you can write from this as well. Their union can be written as 1, 2, 5, 6, 7, 8, 9, 10. Therefore, from 1 and 2, we get A intersection B complement is equals to A complement union B complement. It's very easy. One thing is that A intersection B complement means A complement union B complement. म्हणजे हा intersection आणि जर कॉम्प्लिमेंट असेल तर त्याचा काय होत असतं युनियन आणि युनियन असेल तर त्याचा इंटरसेक्शन होत असतं. नेक्स्ट इज A is equals to A intersection B union A intersection B complement. This we want to prove. For this we will require A, B, their intersection, then A, B complement. Now A is equals to 1, 2, 3, 4. A intersection B is equals to 1, 2, 3, 4 intersection 3, 4, 5, 6. And their common is 3 and 4. Therefore, B complement is equals to 1, 2, 7, 8, 9, 10. Therefore, A complement intersect A intersection B complement. Now this is A and B complement, which is 1, 2. Therefore, A intersection B union A intersection B complement is equals to 3, 4 union 1, 2. Therefore, 1, 2, 3, 4. Therefore, from 1 and 2, we get A intersection B union A intersection B complement. Now next is B is equals to A intersection B union A complement intersection B. Now here B is equals to 3, 4, 5, 6. A intersection B is equals to 1, 2, 3, 4 intersection 3, 4, 5, 6. Therefore, A intersection B is equals to, I want to see one thing. Now you can see that by mistake it is written as 5, 6, but the intersection of these two set is 3, 4. Therefore, now A complement is equals to 5, 6, 7, 8, 9, 10. A complement intersection B is equals to, that is a 5, 6, and that's why A intersection B union A complement intersection B is equals to 3, 4 union 5, 6. Therefore, 3, 4, 5, 6. Therefore, from 1 and 2, B is equals to A intersection B union A complement intersection B. 7th, A union B is equals to, in bracket A minus B union A intersection B union B minus A. These type of the different adjustments are there, different types of the combinations they had taken. See this here. We first consider the LHS A union B, that is a 1, 2, 3, 4 union 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is A union B, number 1. A minus B is equals to 1, 2, 3, 4 minus 3, 4, 5, 6. Therefore, it is only 1, 2 because this is their subtractions. Which are the common element 3, 4 and 3, 4. Therefore, 1, 2 is remaining only. A intersection B is equals to 1, 2, 3, 4 intersection 3, 4, 5, 6, which are the common element. 3, 4 is a common element. B minus A is equals to 3, 4, 5, 6 minus 1, 2, 3, 4, and that's why you will get 5, 6. We subtract the common element. B minus A is equals to 5, 6. A minus B union A intersection B union B minus A is equals to, now we substitute here all the values of above, that is A minus B is 1, 2. A intersection B is 3, 4. And B minus A is 5, 6. And that's why you will get 1, 2, 3, 4, 5, 6. This is number 2. Therefore, from 1 to we get A union B is equals to A minus B union A intersection B union B minus A. This is we want to prove. Now the 7th one. Now the next is A intersection B symmetric C is equals to A intersection B symmetric A intersection C. Now first B minus C is equals to 3, 4, 5, 6 minus in curly bracket 4, 5, 6, 7, 8. And which is the common, which is the subtraction there? That is a 4, 5, 6. 4, 5, 6. 3 is remaining only. Now next is C minus B. 4, 5, 6, 7, 8 minus 3, 4, 5, 6. Their subtraction, which is that 3, 4, 5, 6. 4, 5, 6. What is the remaining? 7 and 8. Therefore, B symmetric C is equals to B minus C union C minus B. Therefore, B symmetric C, B minus C union C minus B. The first is only the B minus C is a 3 and C minus B is a 7 and 8. What about their union? 3, 7, 8. Therefore, A intersection B symmetric C is equals to 1, 2, 3, 4 intersection 3, 7, 8. And their common element is 3. Therefore, A intersection B is equals to 1, 2, 3, 4 intersection 3, 4, 5, 6. That is equals to 3, 4. Therefore, A intersection C is equals to 1, 2, 3, 4 intersection 4, 5, 6, 7, 8. And we have only the single fourth element. A intersection B minus A intersection C. Now in this case 3, 4 minus 4 and only 3 is there. Therefore from 1 and 2 therefore A minus C minus A intersection B is equals to 4 minus 3, 4. Therefore empty set is there. And hence A intersection B symmetric A intersection C is equals to, now this is again written as A intersection B minus A intersection C union A intersection B minus A intersection B, and therefore C union empty set, and that is equals to 3. Therefore from 1 and 2 A intersection B symmetric C is equals to A intersection B, symmetric A intersection C. N of A union B is equals to N of A plus N of B minus N of A intersection B. You also see at the same type the textbook, because you must know the elements in every test set. Now A is equals to 1, 2, 3, 4, B is equals to 3, 4, 5, 6. N of A is equals to 4, N of B is equals to 4. N of A union B is equals to 1, 2, 3, 4, 5, 6. Therefore, N of A union B intersection B, their common elements 3, 4. Therefore, N of A union B is equals to 6. N of A intersection B is 2. N of A plus N of B minus N of A intersection B is equals to 4 plus 4 minus 2 is equals to 6. That is equals to N of A union B. Therefore, N of A union B is equals to N of A plus N of B minus N of A intersection B. N of B is equals to N of A complement intersection B plus N of A intersection B. Now the set B is 3, 4, 5, 6. N of B is equals to 4. A complement is 5, 6, 7, 8, 9, 10. A complement intersection B is equals to 5, 6, 7, 8, 9, 10 intersection 3, 4, 5, 6. Their common is 5, 6. A complement intersection B is 5, 6. N of A complement intersection B is 2. A intersection B is equals to 1, 2, 3, 4 intersection 3, 4, 5, 6. We get 3, 4. Now next is N of A intersection B is equals to 2 elements are there. Therefore, N of A complement intersection B plus N of A intersection B is equals to 2 plus 2 is equals to 4. And this is nothing but N of B. Therefore, N of B is equals to N of A complement intersection B plus N of A intersection B. N of B is equals to N of A complement intersection B plus N of A intersection B. Now next is question number 6. If A and B are subsets of the universal set X and N of X is equals to 50, N of A is equals to 35, N of B is equals to 20, A complement intersection B complement is equals to 5, find N of A union B. Now this is the simple question. N of X is 50 and N of A intersection B complement is equals to 5. Now see this here, A complement intersection B complement is nothing but A union B complement. Therefore, N of A union B complement is equals to N of A complement intersection B, that is equals to 5. Therefore, N of A union B is equals to N of X minus N of A union B complement, and that is equals to 50 minus 5, which is equals to 45. Therefore, N of A union B is equals to 45. Second, N of A intersection B is equals to N of A plus N of B minus N of A union B. 35 plus 20 minus 45, and that is equals to 10. 55 minus 45, that is equals to 10. N of A intersection B is equals to 10. Third, N of A complement intersection B is equals to N of B minus N of A intersection B. 20 minus 10 is equals to 10. n of A intersection B complement is equals to n of B minus n of A intersection B. That is equals to 35 minus 10, that is equals to 25. Now see this again. That is equals to 10. Next is third one. N of A complement intersection B is equals to n of B minus n of A intersection B. All these formulae you have to remember. And every time you see in the textbook, what are the elements in the set? Then you can solve this, because all these are very sets, different type of the sets. That is n of B is 20 minus 10, that is equals to 10. N of A intersection B complement is equals to n of A minus n of A intersection B, that is 35 minus 10, that is equals to 25. Therefore, n of A intersection B complement is equals to 25. Now next is, in a class of 200 students who are appeared certain examination, 35 students failed in CET, 40 in NEET, 40 in JEE. Now see this again here. In a class of the 200 students who appeared certain examination, 35 students failed in CET, 40 in NEET and 40 in JEE. Now the next 20 failed in CET and NEET. 20 failed in CET and the NEET. Next, 17 in NEET and JEE. 15 in CET and JEE. And 5 failed in all the 3 examinations. Find how many students did not fail in any examination, failed in NEET or JEE entrance. Let capital X set of all students. C is equals to set of students failed in CET. N is equals to set of students failed in NEET. And J is the set of the student failed in JEE. Now see this in this case. See, their corresponding letters are here. Here is I. It's this letter is stated as a J. I will change it. Now we have Nx is equals to 200. N of C is equals to 35. N of N is equals to 14. N of J is equals to 40. I had changed here. By mistake it is written as I. Now the next is N of C intersection N. That is a failed in NEET and CET. That is a 20. Next is number of the student who failed in both NEET and JEE, 17. Number of the student who failed in CET and the JEE, 15. Therefore, the N of C intersection N intersection J. Those students who failed in all these examinations. Now these are the 5 students I am seeing this question because the screen is up and down. The Venn diagram. Now see this Venn diagram. First is all these the C, CT, and NET, and last is JE. In this case, you can see this, the number of the student who failed. Now again, you can see the again very good figure. These are the 5 students failed in all. Next is the number of a student who did not fail in any examination is n of C union n union j complement. Now in this example, that is these are the failed students, but we'll require the student who do not fail. Therefore, we will find out the complement of this. Therefore, n of C union n union j complement is equals to n of x minus n of C union n union j. How many students are there? 200 students are there. Therefore, the subtraction, all the failed student, now see this, and taking the total of all these, that is equals to, now see this here, that is a failed student, C union N union J. This is a 5 plus 15 plus 8 plus 10 plus 5 plus 12 plus 13. All the students are here. All these are the failed student. If we subtract from 200, then we will get the pass candidate. And that is equals to, the answer is, again see this, the final answer, minus 68, that is equals to 132. These are the students who do not fail in any examination. Now next is second, the number of students who fail in NEET or JEE entrance, that is n of A n union J is equals to, this is the sum of the all the elements, that is 15 plus 8 plus 10 plus 5 plus 12 plus 13, that is equals to failed in NEET and JEE. Now we can see this here, 15 plus 8 plus, that is equals to 13, 63. From the amongst 2000 literate individual of a town, 70% read Marathi newspaper. Now the question number 8. From amongst 2000 literate individual of a town, 70% read Marathi newspaper, 50% read English newspaper, and 32.5% read both Marathi and English newspaper. Find the number of individuals who read at least one of the newspapers, neither Marathi nor English newspaper. Third, only one of the newspapers. So this is the figure. In figure X, the set of all illiterate individuals. A is equals to the set of individuals who read Marathi newspaper. B, the set of individuals who read English newspapers. We are given the following: n of x is equals to 2000, n of a is equals to 70% of 2000, that is 1400, n of b is equals to 50% of 2000, that is equals to 1000, n of a intersection b is equals to 32.5% of 2000, that is 650. The Venn diagram is shown in the figure. Therefore, this is the Venn diagram. The number of individuals who read at least one of the newspaper, that is n of a union b, that is equals to 750 plus 650 plus 350. Now see this answer. That is equals to 1750. Second, the number of individuals who read neither Marathi nor English. Neither Marathi nor English newspaper. N of a union b complement is equals to n of x minus n of x minus n of a union b. 2000 minus 1750, that is equals to 250. This is the individuals who do not read the newspaper. Next is number of individuals who read only one newspaper, that is n of a intersection b complement plus n of a intersection b. Now first is T, the set of students who take tea. C, the set of students who take coffee. M, the set of students who take milk. We are given the following, that is n of t is equals to 25. Second, n of c, that is those who take the copy. Now see this here, n of t, who take the t, that is a 15 plus 10, it is equals to 25. Coffee, that is a 2 plus 8, 10, 10 plus 10, 20. And the milk, that is a 8 plus 7, that is equals to 15. Now next, those who take, that is a tea and coffee, both, there are 10, it is written here. Those who take coffee and milk, they are 8. Therefore, the next is n of m intersection c is equals to 8. N of t intersection m is equals to 0. T intersection m, they, both of them do not have any common. Therefore, from figure, that is Venn diagram, the number of students in the hostel is equals to n of t union c union m, that is equals to, that is a 15 plus 10 plus 2 plus 8 plus 7, and that is equals to 42. Question number 10. There are 260 persons with a skin disorder. If 150 are had been exposed to the chemical A, 750 to the chemical B, 36 to both chemicals A and B, find the number of persons exposed to. First is chemical A, but not chemical B. Second, chemical B, but not chemical A. Third, chemical A or chemical B. Let X is equals to the set of all persons. A is equals to the set of persons exposed to chemical A. B, the set of person exposed to chemical B. C, that is next is, we will write all this now. N of X is equals to, that is a 260. N of A is equals to 150. N of B is equals to 74. N of A intersection B, that is equals to 36. Now see this Venn diagram is as follows. Now this is the figure. From the figure, that is, again I will say this question. That is there are the 260 person with a skin disorder. If 150 had been exposed to the chemical A, 74 to the chemical B, and 36 to both chemical A and B, find the number of person exposed to A but not B, chemical B, not chemical A, and A or B. Now in this case, N of A is equals to 260, N of A is equals to 150, N of X is equals to 260. Therefore, From the Venn diagram, we'll write here. From the Venn diagram, the number of person exposed to chemical A, not the chemical B. Now there are only 114. Now see this here. A intersection B complement, that is equals to 114. I forget to write here complement. A intersection B complement. The number of person exposed to the chemical B but not A. Therefore, it is written as, that is equals to 38. A complement intersection B. Here B complement must be there. I forget to write it. Third, chemical A or chemical B. Now we want to find out their A union B or the chemical B. The number of person exposed to the chemical A or chemical B, N of A union B is equals to, that is equal to 114 plus 36 plus 38, and that is equals to 188. Now the question number 11. Write down the power set of A. It's very simple. That is, the number of the elements are the set of all possible subset of A. P of A is equals to, if A has n elements, then P of A has 2 raised to n elements. If n of A is equals to 3, therefore n of P of A is equals to 2 raised to 3. That is equals to 8. Therefore P of A is equals to 5, 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and in this way. Therefore n of P of A is equals to, that is equals to 8. Now the question number 12. Write the following intervals in set builder form. That is an open interval -3, 0. X is such that X belongs to set of real number and X lies between -3, 0. Closed interval 6, 10. X is such that X belongs to set of real number and X lies equals to 6 and 12. Now whenever there is a closed interval, there is always less than or equal to. When there is an open interval, then it is a strictly less, that is this X is a strictly greater than X and this X is strictly less than 0. But in this case, this is the closed interval 6, 12. Therefore X lies between 6 and 12, equal to 6 and equal to 12. Now see this again. Next, 6 infinity. X is such that X belongs to set of real number and X is greater than 6. Minus infinity and closed interval 5. Now see this, X is such that X belongs to capital R and X is less than or equal to 5. Therefore, it is the open interval minus infinity and closed interval 5. Now open interval 2 and closed interval 5. Therefore it is, this is x is such that x belongs to set of real number. Now here 2 is open here, that is the 2 is not included here, and that is a less than or equal to 5. Minus 3, 4, that is a closed interval minus 3, open interval 4. Now here is x is such that x belongs to set of real number, and this x lies between minus 3 and 4. Let's see again here. Question number 13. A college awarded 38 medals in volleyball, 15 in football, 20 in basketball. The medals awarded to a total of 58 players. Only 3 players got the medal in all 3 sports. How many received the medal in exactly 2 of the 3 sports? That is 2 of the 3 sports. जो त्या एकाला दोघांमध्ये मेडल मिळाले हे आपल्याला फाइंड आउट करायचे आहे. V is equals to the set of student getting medals in volleyball. F is equals to the set of students getting the medals in football. B is a student, set of the student getting the medals in basketball. We are now here. N of V is equals to 38. N of F is equals to 15. N of B is equals to 20. N of V union F union B is equals to 58. N of V intersection F intersection B is equals to 3. Now see this here figure. Now from the given figure, here is a B for the basketball, V for the volleyball, and F for football. Now see this here, small a, small b, small c. These are the students who got, that is exactly 2 of the 3 sports, medals in the 2 of the 3 sports. How many students? That is the volleyball and the football got 2 of these. Student got the medal of volleyball and the football. They are A. Student who got the medal in basketball and the football is B. Student who got the medal in basketball and volleyball, they are C. Now 3. These are the students who got the 3 medals. That is, they got in each play. That is a volleyball, basketball and football. Now see this here. A is equals to the number of students getting the medals in volleyball and football. This is here. And not in the basketball. Now next is a B is the number of the students getting the medals in football and basketball and not in volleyball. C is equals to the number of students getting medals in basketball and not in volleyball, not in football. C is the number of the students getting, see this here. C is the number of the students getting the medals in basketball and volleyball, but not in football. In this way, A, B, C. We have defined this A, B, C. Now 38. V is equals to the number 38. These are the students who got the medals in volleyball. Now here is the 38. Now these are the students which shown in the blue in. They are the students who got only the in football. That is 38 minus in bracket this A plus 3 plus C. Again next, that is a number of the students who got the medal in football. They are 15. But only the football means what? That is a 15 minus in bracket A plus B plus 3. And the last, that is the number of the students who got the medal in basketball are the 20. Now here is not 0 there, but these are the students who, they are the 20 students. Therefore we subtract here, that is a 20 minus in bracket B plus C plus 3. Now next is from the Venn diagram. That is n of V union F union B is equals to in square bracket 38 minus in bracket A plus C plus 13 bracket complete plus 15 minus in bracket A plus B plus 3 plus 20 minus in bracket B plus C plus 3 bracket complete plus A plus B plus C plus 3. These are all 58. Now we'll add it. 38 plus 38 plus 15 plus 20. Next is minus 3 minus 3 minus 3, all these 3. One is plus 3 minus in bracket A plus C minus in bracket A plus B minus in bracket B plus C plus A plus B plus C. Now solve this, you will get, that is a 58 is equals to 67 minus in bracket A plus B plus C. Therefore A plus B plus C is equals to 67 minus 58, and that is equals to 9. Therefore the number of players who received the medals in exactly 2 of 3 sports, A plus B plus C is equals to 9. Therefore again You can see this here. That is equals to 9. Next question. Question number 14. Solve the following inequalities and write the solution set using interval notation. We want to write the interval notation. Now to solve this, that is a 2x plus 7 lies between minus 9 and 19 and equal to 90. Now to solve this equation, now see this, subtract on both sides by 7, therefore you will get 9 minus 7 less than 2x plus 7 minus 7 less than or equal to 19 minus 7, and that is equals to minus 16 less than 2x less than or equal to 12. Therefore divide on both sides by 2, that is a minus 8 less than x less than or equal to 6. Therefore the solution set is minus 8 and closed interval 6. Second, x square minus x greater than 20, x square minus x plus 1 upon 4. Now to make this in a perfect square form, this is the middle term. Using this middle term, we can find out the second term. Then what will be the second term? 1 upon 2 will be the second term. Therefore, x square minus x plus 1 upon 4. We add on both sides by 1 upon 4. Therefore, you will get x square minus x plus 1 upon 4 greater than 20 plus 1 upon 4. Now the simplification of this is that the middle term is equals to 2 into first into second term. We can find out that term. Now this is 1 by 4. That is the middle term is equals to, what is middle term? Minus x equals to 2. First term is x. Second term. Now what's happening here? That is a minus 1 is equals to 2 is multiplied here. Therefore second term is 1 upon 2. And it's a square. We add here square of 1 upon 2. Then this will be the perfect square. That is x minus 1 upon 2 bracket square. Next simplification. That is x minus 1 upon 2 bracket square is greater than 81 upon 4. That is 20 into 4. 80. 80 plus 1, 81 upon 4. Now next is taking the square root x minus 1 upon 2 less than minus 9 by 2, or x minus 1 upon 2 is greater than 9 upon 2. Therefore, you will have that is x minus 1 upon 2 less than minus 9 upon 2, or x minus 1 upon 2 greater than 9 by 2. Now add on both sides. That is 1 upon 2. That is x less than minus 9 by 2 plus 1 upon 2. Or x is greater than, add on both sides 1 upon 2. That is x is greater than 9 by 2 plus 1 upon 2. Now if we simplify this, that is minus 9 by 2 plus 1 upon 2, you will get minus 4. And if we add these two, 9 upon 2 plus 1 upon 2, then you will get 5. That is x is greater than 5. What's happening here? X is less than minus 4 and x is greater than 5. It means that the value of the x is x is less than, now again see this here, that is x is less than minus 4. It means that minus infinity to minus 4. This is the interval, open interval. What about the next? X is greater than 5 means 5 to infinity. These are the two open intervals. Now next is number 3. That is a 2x upon x minus 4. This can be again written as their simplification. 2x minus 8 plus 4 upon x minus 4 less than or equal to 5. That is a take here. We'll divide it's like this. That is a 2x minus 8. Let's take 2 as common. Then in bracket x minus 4 upon x minus 4 plus 8 upon x minus 4 less than or equal to 5. Therefore, now this is written as 2 plus 8 upon x minus 4 less than or equal to 5. Therefore, 8 upon x minus 4 less than or equal to 5 minus 2. Therefore, 8 upon x minus 4 less than or equal to 3. Now, next simplification. If x is less than 4, then no problem. If x is less than 4, then this fraction will be the negative. Then x is less than 4, 8 upon x minus 4 is negative. Hence, x is less than 4 satisfies the inequality 1. What about the second? If x is greater than 4. If x is greater than 4, then what will happen? X minus 4 greater than 0. If we simplify this, subtract on both sides by 4. 4 minus 4 will become 0. X minus 4 greater than 0. And the next is 8 upon x minus 4 less than or equal to 3. Now if we simplify here, then you will get 8 less than or equal to 3 in bracket x minus 4. After simplification, 8 is less than or equal to 3x minus 12. That is 8 plus 12 less than or equal to 3x. Therefore, 20 less than or equal to 3x. 20 upon 3 less than or equal to x. This is number 2. Therefore, from 1 and 2, we have the solution. Set is one is x is less than 4 and another is x is less than 4 means what? Minus infinity to 4. And next is 20 upon 3 up to the infinity. These are the numbers. You can see again here. That is a 20 upon 3 less than or equal to x. Therefore, next, number 4, 6x square plus 1 less than or equal to 5x. Now simplify this. We can now divide on both sides by that is 6x square plus 1 less than or equal to 5x. It means that subtract on both sides by minus 5x, then this 5x get cancelled. You will get 6x square minus 5x. But how this minus 1 is there? Again subtract on both sides by minus 1. Then you will get 6x square minus 5x less than or equal to minus 1. Now 6x square minus 5x less than or equal to minus 1. Divide on both sides by 6. Then you will get x square minus 5 upon 6x less than or equal to minus 1 upon 6. Now in this case x square minus 5x upon 6x plus. Now here is, what is the second term? The second term will be, that is a 20, that is 5 upon 12, and its square is 25 upon 144. Therefore add on both sides by 25 upon 144. That is x square minus 5x upon 6 plus 25 upon 144 less than or equal to minus 1 upon 6 plus 25 upon 144. Therefore, you will get x minus 5 upon 6 bracket square less than or equal to, that is a 1 upon 144. That is taking the square root on both sides, then you will get. Now there is again also questions from you. That is how this equality gets. That is, once you will get minus, if you take the square root on both sides, x minus 5 by 6 less than or equal to 1 upon 12. And when it is a minus sign, then there is a reflection. That is, x minus 5 by 6 is greater than minus 1 upon 12, greater than or equal to. When we take the square root on both sides, the positive equality remains as it, inequality remains as it is. And when we take it, then here is a reflection. That is a less than or equal to become greater than or equal to. That is a x minus 5 by 6 is a greater than minus 1 upon 12. Therefore, it is written as like this. And this is less than 1 upon 12. And in this way. Next is, we have this. Now simplification of this. That is to remain here x. फक्त इथे x राहिला पाहिजे. म्हणजे काय करणार आपण, या सगळ्या इनइक्वालिटीज मध्ये 5/12 आपण ऍड करणार. Therefore you will get minus 1 upon 12 plus 5/12 less than or equal to x less than or equal to 1 upon 12 plus 5/12. And if we simplify this, that is minus 1 plus 5. Therefore you will get 4 upon 12, that is equals to 1/3 less than or equal to x less than or equal to, if you add this, at 6 upon 12, then you will get 1 upon 2. Therefore the set is 1 by closed interval 1/3 1 upon 2. Therefore the solution set is 1/3 1 upon 2. Now the question number 15. If a is equals to minus 7 3, b is equals to closed interval 2 6, and c is equals to closed interval 4 9, then find a union b. Now to find out the a union b, now see this, how the set is written. A is equals to open interval minus 7 and closed interval, closed bracket here, open and the close. That is minus 7 is open and the 3 is a closed here interval. Now in this case 7 is not included. That x is such that x belongs to set of real number and x lies between minus 7 and 3 and equal to 3. But it is not the minus 7, it is a greater than, strictly greater than minus 7. It is written as in this manner. Now next is b is equals to closed interval 2 6 and x is such that x belongs to set of real number and x, that is a 2 less than or equal to x less than or equal to 6. C is equals to in closed interval 4, 9. X is such that it belongs to set of real number and X lies between 4 and 9 equal to 4 and less than equal to 9. Therefore, you will get A union B is equals to X is such that X belongs to set of real number and this X lies between -7 and 3 and equal to 3. Union. Now this is the union of these two sets A and B. What about the next? X is such that it lies between 2 and 6 equal to 2 equal to 6. We want to union of this. Now what is the less amount? Less amount is -7. And what is the greatest amount? The greatest amount is 6. Now see this here. Therefore, you will get the answer. X is such that it belongs to set of real number and this is the final answer. What is the least one? Least one is -7. What is the greatest one? Greatest one is 6. Therefore, X lies between -7 and 6 and equal to 6. Which is written as like this, that the -7 is open and 6 is closed. Now, next is second one, B union C. That is equals to in curly bracket X is such that X belongs to set of real number. X lies between 2 and 6 union X is such that X belongs to set of real number and X lies between 4 and 9 equal to 4 and equal to 9. It means that what is the least one? The least one is 2. What is the greatest one? Greatest one is 9. Now see this here. Their union X is such that it belongs to set of real number and in this way this is the least one and this is the greatest one and that is equals to closed interval to 9. Now next is A union C is equals to X is such that X belongs to set of real number and X lies between -7 and 3 and less than or equal to 3. Union X is such that X belongs to set of real number and X lies between 4 and 9 equal to 4 equal to 9. This is written as open interval -7 closed interval 3. Therefore union closed interval 4 9. Now the fourth one, A intersection B. X is such that X belongs to set of real number. X lies between -7 less than or equal to 3 intersection. X is such that X belongs to set of real number. X lies between 2 and 6 and equal to 2 equal to 6. Again, what is the least one? The least one is -7 and the greatest one is 6. There the common points. Now we'll require the common, which is the in between them. X is such that X belongs to set of real number. Now what's happening here? That is -7 to 3. It means that here is a 2. Here is also 2. What is the least one from these? The common is 2. And what about here? The least one. Here is a 3 and 6. Therefore least is that is equals to the common is 3. 2 and 3 here. -7. -7 means what? -7, -6, -5, -4 and in this way. Therefore common for these two intervals is X lies between 2 and 3 equal to 2 equal to 3. Now next is fifth one, B intersection C. Again here C this here. X belongs to set of real number. Now again which is the common? This is a 4. That is, here start from 2 and here is a 4. Therefore, we have to take here 4. 4, 5, 6. That is, the x is lies between 4 and 6. Equal to 4 equal to 6. Therefore, x is such that this is the written as in this manner. 4, 6, there is a closed interval. Now 6, 1, A intersection C. That is, x is such that x belongs to set of real number and x is such that x belongs to set of real number. Next is this is. Now they are common. Now here minus 7 to here is a 3. Minus 7 to 3. But what about here? Here is a 4 to 9. These are the totally disjoint and therefore they do not have any common. That is equals to empty. Now next is 7th is A complement is equals to R minus A. Now the set of real number, that is R minus A. X is such that x belongs to set of real number and x lies between minus 7 and 3 and equal to 3, and therefore x is such that x belongs to set of real number and x is less than or equal to minus 7 or x is a greater than 3. This is important. Now see this here, one thing, R minus x is such that x belongs to set of real number. X lies between minus 7 and 3 and equal to 3. Means that if you subtract this interval, then you will get x is such that x belongs to set of real number x. Now here is a, that is a less than, strictly less than, but here x is less than or equal to minus 7. What about here or? Here is a less than or equal to and it becomes greater than 3. X is greater than 3 and in this way you have to remember. Now here see this, the x is less than or equal to minus 7 and it is written as minus infinity to minus 7. X is greater than 3 means what? This is the open interval from 3 to infinity. A complement intersection B is equals to now, that is minus infinity to minus 7. That is a closed one and another is this is, that is a 2, 6. Therefore their intersection is a starting from, this is a 2 to 6, okay, and here is a 3 to infinity. Now which is the greater one? After the 2 we get the 3. Therefore 3 up to the infinity, but here is a closed 6. Therefore we take here 3 as open and 6 as a closed. These two are the important points, 3 and 6. 8th one, B complement is equals to R minus B. Now write down the B. X is such that x belongs to a set of real number. X lies between 4 and 9. Therefore, x is such that x belongs to a set of real number. X is less than 2 or x is the greater than 6. Therefore, C dash is equals to R minus C. Therefore, x is such that x belongs to a set of real number and this x lies between 4 and 9, equal to 4 and equal to 9. Therefore, again it is written as x is such that x belongs to a set of real number. Now again here, that is x, 4 is less than or equal to x. Then it becomes x is strictly less than 4. Or what about here? X is less than or equal to 9. Then it becomes x is strictly greater than 9. This is important that you have to remember it. B complement intersection C complement, that is a x is such that x belongs to set of real number, x is less than 2 or x is greater than 6. Therefore, intersection, these are the main points. Now the intersection common of these two, x is less than 2, x is less than 4. Therefore, which is the common one? X is less than 2, x is less than 4. Now, from these two, x belongs to set of real number, x is less than 2. And what about here? X is greater than 6 and x is greater than 9. Therefore, here we have the minus infinity to 2 open, and here is from 9 to plus infinity, and this is the next one is the ninth one, b minus c, that x is belongs to set of real number and x lies between 2 and 6, minus x is such that x belongs to set of real number and x lies between minus 4 and 9. Now again see this here, that is the minus of these two, which we can take here, that is the minus 4 to this. Again you will get 2 and 4 is in mid between this, that is a 2 and 4. Therefore, that is a open interval 2 and the closed interval is 4. And that's 10th one, a minus b. X is such that x belongs to set of real number and x lies between minus 7 less than or equal to 3. And it is minus x is such that x belongs to set of real number and x lies between 2 and 6 equal to 2 equal to 6. X is such that x belongs to set of real number, x lies between minus 7 and 2. Therefore, done all this. You can find and write down it. That is the b complement is equals to r minus b, c complement is equals to r minus c, and in this way we have completed this exercise 5.1. It's very tough one. When you learn this video, you will see this video, you take also the textbook and see the questions what I had done there. I hope that you will understand whatever that I try to explain. Now we'll see in the next video Till then, goodbye.